Hello children, welcome to Riot Tuition Classes. We are doing chapter 1, force. In that part B, center of gravity. Okay. Now first thing children, before I go to this, what is the meaning of center of gravity? I would like to tell you what is gravitational force. Okay, what do you mean by gravitational force? Actually, gravitational force is a force of attraction between two material bodies. If two material bodies are close by to each other, if two material bodies are close to each other, body A and body B are close to each other, they exert a force of attraction on each other. Got it? This force of attraction is called a gravitational force. Okay. So just like that, suppose we have one body, okay, and you have your earth here. This is earth. So the earth exerts a force of attraction on this body. Beta, earth being the size of the earth is very, very big. That's why I say the earth exerts a force of attraction. Are you getting me here? This force of attraction is nothing but an example of gravitational force. But ये force of attraction को एक special name दिया गया है, force of gravity. Okay, so force of gravity is nothing but the gravitational force exerted by the earth on every material body. Force of gravity is nothing but the force of gravity is nothing but force of attraction exerted by the earth on every material body. I hope you're understanding me here. Or you can also call it as weight of the body. You can also call it as weight of the body. I repeat for the last time, beta. What do you mean by gravitational force? Gravitational force is nothing but force of attraction between the two material bodies. Now, Earth is one big body, and then you have your given body, okay? There's a given body. Earth is one, another big body. So the earth exerts a force of attraction. Now, I don't say the body exerts a force of attraction on earth, but I better say earth exerts, because earth size of the earth is much, very big, much bigger than the body. So I say the earth exerts a force of attraction on this body. Now, this force of attraction, we call it as force of gravity, or we can also call it as weight of the body. Are you getting me here? Got it? Weight of the body. So force of gravity is nothing but a gravitational force of attraction exerted by the earth on a body. Got it? Now, this body, the size of the body and size of the earth, just now I said, when you try to compare, beta, the size of the earth is huge, and this body can be imagined as a particle. So every body can be treated as a particle. So I can use a word. Earth exerts a force of attraction on every particle. Are you getting me here? This force is called force of gravity or weight of the body. Now what I say, children, one step ahead. Suppose I have one body, okay? A body. Please have a look here. I have a body. I rub it off and try to tell you now in a different way. Suppose I have a body, okay? This body can be imagined to be made up of many particles. This body can be imagined to be made up of many particles. I'm doing only few particles here. That doesn't mean. You can imagine this body to be made up of particles. Got it? I'm showing few particles. Now, all these particles, the earth exerts a force of attraction on all these particles in a downward direction. Are you getting me up? Or it exerts a force of attraction on all these particles, which, okay, you can see here in a downward direction. In a downward direction. Got it? And all this, suppose, please have a look here, the weight of this particle. So I call this as force of attraction exerted by the earth on all these bodies. I can call it as a weight of the particles. I can call it as weight of the particles. So I can take this weight of the particles as W1, W2, W3, W4, W5, W6, W7. Okay, I can just consider. I can have infinite particles and all these particles will have the weight. Are you getting me? And all this weight are acting in a downward direction, that is towards the center of the earth. They are acting towards the center of the earth. They are acting towards the center of the earth. Now, I told you this earth, the size of the earth is very, very, very big compared to that of this body. So all these lines which are drawn representing the forces, I have shown them parallel. So you can imagine these forces are the forces exerted by the earth and all these particles. That is, the force of gravity of the particles are parallel to each other. You can imagine this because the size of the earth is very, very big compared to the size of the body. Got it? So, हर एक particle earth exerts a force of attraction on it. उसको force of gravity बोलेंगे या weight of the particle बोलेंगे. So some weight downward direction में है. तो इसके कारण सबको हम लोग पैरेलल कंसीडर कर सकते हैं. क्यों पैरेलल कंसीडर कर सकते हैं? बिकॉज द साइज ऑफ द अर्थ इज वेरी वेरी बिग than the size of this body. So this can be considered parallel. All these forces, got it? W1, W2, W3, all these are forces. Okay, W4, W5, W6, W7, W8, all these are acting parallel. Now, if the forces are parallel forces, then please have a look here. According to physics, I can represent, because of these parallel forces, I can represent all this, I can represent them together by one single force towards the center of the earth. Okay, I repeat, since this forces, line of action of this forces are parallel, you can imagine. So I can represent all this together by one single line at one point, acting at one point towards the center of the earth. Got it? Now that point, the question is where that point should be. Got it? फिर से मैं बोल रहा हूँ, ये सब line of action जो है parallel to each other, because मैंने बताया ये particle, the earth का size तो बहुत बड़ा है, and these are the forces towards earth, force of attraction towards earth. तो ये सब line of action को मैं parallel consider कर सकता हूँ. अभी parallel consider कर सकता हूँ, then according to physics we have learned, okay, vectors name, then all this can be represented by one single resultant force. Are you getting me? By the single resultant force, which is nothing but sum of all these forces. Are you getting me? But that resultant force, at which point it should act? That point किधर रहेगा भाई? किधर मंगता उधर नहीं रह सकता है. Got it? So I'll just tell you, I want to identify that point, okay? Where, please have a look here, where the resultant of all these forces together, I can say, is acting at that point. Are you getting me here? So that point, kaisa nikalunga. So I'll just tell you, children, listen here. Suppose this is a seesaw, okay? And this seesaw is somewhere in the middle. You can see it's pivoted, okay? Now, suppose a person sits at this point A. So, he will exert an anti-clockwise movement. Suppose a person B sits on this. He will bring out a clockwise movement. If this anti-clockwise movement and clockwise movements are equal, then about this point, okay, this will remain balanced it will remain in a balanced condition. So, just like that, I will try to identify one point in such a way that the anti-clockwise movement about this point and the clockwise movement about these points are equal. That is the sum total of the movements, because anti-clockwise movement को क्या लूंगा मैं positive, और please have a look here, anti-clockwise movement को positive और clockwise movement को negative. तो दोनों को ऐड करूंगा तो मुझे जीरो आएगा, क्योंकि अगर दो इक्वल नंबर +5 -5 ऐड किया तो जीरो आते कि नहीं. तो वैसे ही दोनों मूवमेंट्स, प्लीज हैव अ लुक एट द सम टोटल ऑफ द मूवमेंट्स about that point should be zero. So I have to search this point in such a way, ये जो point है जिसमें मैंने बताया ना, वापस बता रहा हूँ, हर एक पार्टिकल का वेट होता है W1, W2, W3, W4, W5, W6, W7. मैंने ऐसे थोड़ा लिया है इधर. Got it? All this can be considered parallel because the earth is very, very big compared to this body. Okay, all the weight of the particles which are acting in a downward direction, the line of action, I can imagine them to be parallel. Now, if they are parallel, then according to the vectors, you'll not there for you, but they can be represented by one single force, got it, which is nothing but sum total of all these forces. But that single force कौन सा पॉइंट में एक्ट करेगा, वो डाउट, किधर रहेगा वो पॉइंट, वो मालूम नहीं था. तो मैंने क्या बताया कि see about, suppose this is your seesaw, about this point, okay, the anti-clockwise movement and clockwise movement, if they're equal, then the seesaw will remain exactly in horizontal position about this point, balanced. Okay, so just like that, I have to search a point G in such a way that the anti-clockwise movement about that point and the clockwise movement about that point, due to this weight of these particles, they remain equal. That is, the resultant movement of forces due to this weight of the particles about that point is zero. Are you getting me here? So such a point ढूंढ के निकालना, and that point is called center of gravity. That point can be called as center of gravity. This center of gravity is always represented by letter G. Got it? So center of gravity is always represented by letter G. So what is center of gravity of a body? So I can say the center of gravity of a body is a point about which the algebraic sum of the movements of the weights of all the particles constituting the body is zero. Got it? I repeat, beta. What is this? I'll just say, I'll show it to you. What is the center of gravity? Which I told you, this center of gravity of any body is always represented by capital letter G. So center of gravity of a body is a point on the body, about which the resultant moment of force is zero. That is, in other words, I can say the algebraic sum of the movement of forces about that point is zero. अभी calculus zero मैंने बताया, बेटा anti-clockwise movements will be equal to clockwise movement. Anti-clockwise movement क्या रहता है? Positive. Clockwise movement क्या रहता है? Negative. तो एक पॉजिटिव नंबर +5 और -5 को ऐड किया तो क्या आएगा आंसर? जीरो. वैसे ही sum of the anti-clockwise movement and clockwise movement, they're equal. So when I add them, I'll get it zero. So that is the reason why we say center of gravity of a body is a point on the body about which the resultant movement of force is zero. Resultant movement of force, okay, is zero. The resultant movement of forces due to the, okay, I'll add some more sentences so that you'll understand better. Okay, the resultant movement of forces due to the weight of all the particles constituting the body, constituting the body is zero. So center of gravity of a body is a point on the body about which the resultant movement of forces due to the weights of all the particles constituting the body is zero. Got it? So you can imagine the total weight of the body. One can say that the center of gravity of a body, is a point on the body is a point on the body about which the whole weight of the body, weight, the whole weight of the body is concentrated. Correct, children? So try to understand, beta. I didn't have place, so I wrote it here. Got it? I didn't have place, so I wrote it on this. Okay? So understand this. Please have a look here. Okay? So center of gravity of a body is a point on the body about which the resultant movement of forces due to the weights of all the particles constituting the body is zero. Okay, I hope people are understanding. Got it? The weights of few particles, they can bring out, they'll bring out anti-clockwise movement. Here on this side, few particles are there, they'll bring out clockwise movement. If this anti-clockwise movement and clockwise movement are equal about that point, then that point becomes a center of gravity. Got it? So the whole weight of the body is concentrated. One can imagine that center of gravity of the body is a point of the body about which the whole weight of the body is concentrated. Got it? So you can see this. I hope people have got an idea. Now I'm just, what is center of gravity? Okay. So center of gravity, after understanding center of gravity, I will just say, just go ahead. No, we know what is center of gravity now. I'm just telling some certain things which you should know. The center of gravity of a body depends on the shape of the body, depends on the shape of the body, depends on the shape of the body. See, shape, you get shape because of the distribution of mass. Got it? The center of gravity of a body depends on the shape of the body. Got it? It depends on the shape of the body. Got it? The center of body, the center of gravity can also lie outside the body. Got it? The center of gravity can also lie outside the body. The center of gravity can also lie outside the body. Got it? Then by the concept of, like, by the concept of center of gravity, okay, of a body, you can always consider the body to be a point particle of weight W at the center of gravity. Got it? Because of the concept of the center of gravity, the body can be considered, please have a look at any body, okay? The body can be considered as a particle, at its center of gravity, with weight W, got it? So remember, children, these few things you should know about the center of gravity. The center of gravity of a body depends on the shape of the body. Now, if you ask me why shape, how did I come to know it is shape? Suppose I have any metal, in the form of a wire. Okay? I have a metal in the form of a wire. Okay? Now, when it is metal is in the form of a wire, I see the center of gravity is exactly in the middle center of that wire. Got it? The center of the wire. But the same wire, when I make it into a circle, I change the shape. You can see the shape has got changed. That I see the center of gravity comes out of the wire. It is a geometric center of the circle. So that is the reason why I say the center of gravity of body depends on the shape of the body. That is distribution of the mass of the body, you can also see. The next one, the center of gravity can also lie outside the body. It need not be always on the material, got it, inside the body. It can also lie outside the body. The boomerang is the best example, and its center of gravity always lies outside. That is why when you throw a boomerang, it comes back to you. Got it? Because of the placement of its center of gravity. The next one, the body can be considered as particle at its center of gravity. A body can be considered as a particle at its center of gravity with weight W. Okay, children. So few things I told you about center of gravity. Now what I'm saying is, I'm going to show you like a chart, different bodies of different shapes and their center of gravity, because you can always ask, okay? They can always ask, board exam about it, okay, children? So what I'm going to do is the object, okay, and please have a look here, and the object, and here I'll write the position of the center of gravity of that object, position of center of gravity, position of center of gravity of that object, okay? Okay, this object, whichever object I'm talking about, the position of the center of gravity of that object. Are you getting me here? Like, please have a look here. I'm making two columns, okay? This is an object, the name of the object, and the position of the center of gravity, okay? Like, suppose the first object I'm talking about is a rod. A rod is always cylindrical in shape. Got it? A rod is always cylindrical in shape. So what is the position of the center of gravity? It is nothing but you just say midpoint of the rod, midpoint of the rod. Okay, the midpoint of the rod, whatever. Got it? The rod. You know what is a rod, okay? A solid rod. The midpoint of the rod will become the center of gravity. Are you getting me here? The second what I'm trying to tell you is a circular disc. Circular disc, okay? It's a disc, it's a disc. It's a circular disc. So naturally, the geometric center of the disc, geometric center of the disc. What is it? Geometric center of the disc, geometric center of the disc. Okay, children. The next third one, which object I'm going to talk about. The third object, what I'm going to talk about, a solid or hollow sphere, solid or hollow sphere, whatever it is, but it's a sphere, okay? It can be a solid sphere, filled up sphere, or a hollow sphere. Then naturally, it's geometric center. Again, geometric center of the sphere, geometric center of the sphere, okay? It is within, inside, geometric center of the sphere, got it? Okay, the next one, I can say solid or hollow cylinder. This rod is nothing but solid or hollow cylinder. So when you talk about solid or hollow cylinder, naturally, hollow cylinder, it can be a solid cylinder, it can be a hollow cylinder. A rod is an example of solid or hollow cylinder. So naturally, beta, okay, we can say the midpoint of the axis of the cylinder, midpoint of the axis of the cylinder, okay? See, I'll tell you, suppose this is a cylinder, okay? You can imagine its axis somewhere passing through its center. So this midpoint of the axis of cylinder, what it will be the, what you can say, center of gravity, okay? The next one, what will come to is fifth one, okay? We will write it as solid cone, okay, or hollow cone, solid cone. First, I'll talk about solid cone. You know what is a cone, children, okay? But this is a cone, but it's filled up. Now, this is solid cone, matlab filled up, under hollow nahi hai. Got it? So, naturally, at the height, it will be the heavier the thing. Solid cone will be heavier. So, near the base. So, h by 4, okay? If h is a height, if h is the height of the cone, h is the height of the cone, if h is the height of the cone, then the center of gravity will be at will be at h by 4 from the base, okay? H by 4 from the base, okay? And suppose it is an hollow cone. It's an hollow cone. Suppose it's an hollow cone. Again, the same way, if h is the height of the cone, if h is the height of the cone, then the center of gravity, then the center of gravity will be at h by 3 from the base, from the, here also from the base, h by 3, 4 from the base, and h by 3 from the base. Now, when it is h by 4 from the base, it is closer to the base. When it is h by 3 from the base, it's away from the base. So, heavier near the base, hollow away from the base, just to help you remember, okay? Then I'll tell you the seventh one, okay? Like, circular ring. Circular ring. Here, the center of gravity lies outside the ring, but at the geometric center of the ring. At the geometric center of the ring. At the geometric center of the ring. Geometric center of the ring. At the geometric center of the ring. Okay. The next one will be, I'll put it as triangular lamina. Triangular lamina. Triangular lamina is nothing but, you can call it as a triangular surface. Okay. Triangular lamina, I'll say the point of intersection. The point of intersection of the medians. 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 Lastly, when I say parallelogram, okay, rectangle, rhombus, and square. If you ask me, my lamina, matlab my surface is of this type, okay? Okay, my surface is of this type. Lamina matlab surface, okay? Remember, my surface is any of this type, okay? That is, you can see a parallelogram, rectangle, or rhombus, or square, okay? Then the point of intersection of the diagonals, point of intersection of the diagonals, point of intersection of the diagonals will be the, what you can say, axis, will be the axis, center of gravity. So these are few things you have to learn by heart, beta, because I have seen in the board exam, two different figures they'll give. You have to say the point, like, where is this center of gravity is. And for that, they give 2 marks, okay? I think it's a bonus, okay, children? So you should know it. Now, I just go ahead and what I say, suppose this center, we came to know what is center of gravity. Now, any body, okay, I can always balance it by placing on a needle top at the center of gravity. Suppose what I mean is, suppose I have a scale, okay, a 1 meter scale. This is a 1 meter scale. This is what? A 1 meter scale, okay? This is 1 meter scale. 1 meter matlab 100 centimeter scale. 100 centimeter scale. So at this 100 centimeter scale, what is? In this 100 centimeter scale, exactly at its 50 centimeter mark, if I keep it on a needle top, okay, it will remain, it will balance, okay? Like you take a notebook, okay, you take a notebook. The notebook is rectangular in shape. Notebook is rectangular in shape. Exactly the point of intersection of the diagonals. You keep one finger and your notebook will get balanced at that point, okay? So usually these figures, they can be balanced at a needle top at their, what you can say, center of gravity, at their center of gravity, okay, children? Then one more thing, okay, very important what I want to tell you. Please try to understand this, okay? Any shaped body, irregular shaped body, okay? Suppose you make a hole on it, more 3 holes, okay, and you suspend it from a nail, you suspend it from the nail, and just please shake it, let it vibrate, oscillate it. Then it will come to rest. Now, when it comes to rest, see, the body will always come to a rest. Got it? In such a way that the center of gravity will always lie below the point of suspension. Below the point, where it will lie, we cannot say, but below the point of suspension. Suppose there's a point of suspension, it comes to rest, okay? Below the point of suspension, your center of gravity of that body will surely lie. I hope you're understanding me what I'm trying to say. Got it? So I have taken an irregular shaped body. See, any irregular shaped body, I want to locate its center of gravity. So I'm going to take the help of one fact, whenever a body is suspended from a point, just below the point of suspension, got it? Anywhere on that line, below the suspension, the center of gravity lies. So this fact we're going to make use of to identify the center of gravity of this irregular shaped body. So I make 3 holes, A, B, and C on this irregular shaped body, okay? I fix a nail on the wall here at position X. Now what I do, I suspend this irregular shaped body at this point A, at A. So it will remain suspended, okay? It will remain suspended like this. Now what I do, I just take, please have a look at this point, okay? I just, okay. Now from this point, from this nail, I suspend one plumb line, the plumb line. Now what is a plumb line? Plumb line, उसको बोलते बेटा, प्लीज आप लिखिए, एक लाइन, एक रोप रहता है और रोप का एंड में एक मेटल टॉप जैसा रहता है, मेटल का टॉप जैसा, got it? And the plumbers and all use it, or the people, mistris, they use it for seeing whether the wall they're constructing is straight or not, okay? We call this as a plumb line, okay? So the plumb line, I suspend it, okay? The moment it suspend the plumb line, there's a top, okay, metal top. I draw a line along it. Then I'll take this body, I suspend it through this hole B here. B को लेके आके I'll suspend it, again suspend the plumb line, and again draw a line along the plumb line. Again at point C I'll suspend it. C को इधर लेके जाऊंगा, नील को ऊपर सस्पेंड करूंगा, फिर से प्लम लाइन सस्पेंड करूंगा उधर से. तो जब ये तीनों प्लम लाइंस ड्रॉ भी कर लूंगा मैं, एंड वेयर दे मीट, that is the center of gravity. That will be the center of gravity of this irregular shaped body. I hope people have understood me here. Got it? See, any suspended body, one fact you should know, any suspended body just below the point of suspension, but anywhere on the line below it, the center of gravity lies. अभी ये आइडिया को लेके दिमाग में कोई भी बॉडी का सेंटर ऑफ, इरेगुलर बॉडी का सेंटर ऑफ ग्रेविटी हम निकाल सकते हैं. सो व्हाट आई डू, आई हैव एन इरेगुलर बॉडी हियर, उसमें 3 होल्स करता हूं, ए, बी एंड सी, एंड एक नेल लेता हूं, नेल आई what you can say, fix it on the wall. Got it? Now what I do, I suspend this through this hole A. Then I take a plumb line. Plumb line क्या होता है? This is a woolen thread. A woolen thread is fitted to one top, top like metal top. Got it? We call this, masons use it for seeing whether what they're constructing it is in line or not. Okay? We call this as a plumb line. We call this plumb line. So what I do, I suspend this irregular body on that nail through this hole A. Then this plumb line, I tie it and suspend it and draw a line along the plumb line. Then the same body, remove it from the nail. Now fix it at this position, at this hole B. Hole B इधर आएगा, hole B ऊपर आएगा, और फिर से plumb line draw कर लूंगा. फिर C को लेके इसको निकालूंगा और बाद में suspended it through C. Got it? वापस वो plumb line draw कर, plumb line लटकाऊंगा nail के ऊपर, वापस वो line draw करूंगा. तीनों line जिधर intersect करता है, that is the center of gravity of this irregular shaped body. So I hope children, you got an idea of center of gravity. Now, what is remaining is one part C of this chapter. which is nothing but uniform circular motion. We'll do it in the next lecture. Very interesting and very easy to learn. Okay, we do it in the next lecture. Till then, see you all. Bye.